Good morning. For our first interview this morning, I'm here with Ken Zellen, who is International Training Manager for the mythical name of McIntosh. And you're going to tell us what's so hot on your stand, why there were so many people. We're here early, so there's not a lot of people right now. But later on, that's going to be full up. So tell us what's hot.
Well, McIntosh is introducing a new technology. It's called quad balancing in amplifiers. Yeah. And quad balancing is all about getting more dynamic range out of your music and your movies.
Okay.
I should probably define dynamic range. Dynamic range is the difference between how loud the system can play and how quietly the system can play. And how loud it can play is determined primarily by the amount of power we have.
Okay, well, that's where you come in real strong.
We are king on that. We always have been. How quietly a system can play is determined by the background noise level of the electronics.
Okay.
If the noise level is fairly high, quiet parts of the music get buried in noise.
That's logical.
So we just take a measurement of the difference between the highest power and the lowest noise of the system, and that's the dynamic range, which has always been important, but is much more important today with using DVDs and the new high-definition audio and video sources that are coming out. There's a lot more built-in dynamic range, and we need to accommodate that. And with conventional technology, you can only go so far. So we've developed a new technology.
That's what our readers want to know.
Yes. This is called quad differential or quad balancing, and we have 3 sections to our amplifier here. The piece on the left is a 1,000 watt amplifier. 1,000 watts is a lot of power to begin with. The one disadvantage of building a high power amplifier, though, is we tend to have more noise. To build a higher power amp, you need to put in more transistors. Transistors have noise. So as the power climbs, the noise climbs. We're not going to worry about that, and I'll explain why in a moment.
Okay.
Here's another 1,000 watt amplifier, identical to the first one. This produces music, and this produces music also, but the music is upside down. It's inverted, out of phase music. The reason why we do that is the two combine in this third piece. And this is where the magic is. This is where the patents are, is on this piece. That sums the power of the two amplifiers. So 1,000 watts plus 1,000 watts, we have 2,000 watts of total power. But the fun part is it cancels the noise.
Okay.
It flips the noise upside down between the two amplifiers. So whatever noise that produces, the noise of this one cancels the noise of that. And we end up with a noise level, or a signal-to-noise ratio, as we'd call it, of 129 decibels, which is absolutely monumental. Anything over 100 is good, but in a high-power amplifier, getting past 110 decibels of range is the holy grail, what everyone's looked for. We've leapfrogged the rest of the industry.
It's like the huge mountains out here in Denver.
Yes, exactly. All of that would be completely wasted if the earlier stages of the system added noise. So let's take a look at what we're doing to eliminate noise in the earlier stages of the system. And that would be right over here. Well, this is our controller. We make several versions of this, all using the same technology. This one happens to be 2-channel stereo, but we also offer it for home theater and multi-room applications. But the technology is always the same. Let me turn the power on. Right on the front, we have the input selector, and this determines what we're going to listen to. CD, satellite, DVD, VCR, phono, whatever it is. We'll give it another moment. This is a tube unit, so it's warming up. Okay, why don't you go ahead and just turn that knob for me?
Can I do that?
Yeah.
Okay.
Has a nice feel, doesn't it?
Feels real heavy.
Yes, it's a very solid feel. Well, it's actually a fake. It feels like an old-fashioned input selector, because McIntosh customers tend to prefer a knob to little fiddly buttons. But what's happening in this is the actual switching of the musical signals is happening right back here in these little black boxes. 10 years ago, units were made where the music came in the back, and all the music traveled to the front, went to the selector switches, got amplified, back to the back panel, and all of those wires act as little antennas to pick up noise. So we want to avoid that. So here the music comes in the back, and all the switching is done right at the jack. And this is where the fun part is. The switches are ruthenium contacts. Very few people are aware that ruthenium is the best contact material known to man. It's better than gold. And we put these little contacts in glass cylinders, and that prevents any dust from getting in. And then we fill it with nitrogen so no part can corrode. And then the glass cylinder gets encapsulated with metal and plastic. It's kind of exotic.
It's a real learning experience, Ken, that you've been giving our readers. This is fabulous.
Well, we didn't invent it. It's used in nuclear reactors.
Oh,
in nuclear
okay.
reactors, you've got to make sure you get a proper connection.
This I can put in my home, right?
This you can put in your home,
Okay.
and you won't have any nuclear
Well, with
nuclear
2,000
problems.
watts, the neighbors may think I've got a nuclear reactor. You never know.
That's very possible. But what this technology gains for us is by eliminating almost all the wiring and having all switches done in a nitrogen bath, it eliminates the noise. And remember I talked about dynamic range. How much power can we have? Well, an awful lot, as we can see over there. Those amplifiers are 2,000 watts. But all of that is not important if the first unit introduces noise.
Okay.
And here we've eliminated that problem.
Okay. Ken, thank you very much. If people
My
want
pleasure.
more, they'll come to one of your courses. I'm sure you run these things.
Yes, indeed. Thank you very much.
Thank you very much. Thank you.